or geographical information system. So today we'll be having another presentation on introduction to Scratch programming, and I hope you guys are excited, and it will be a fantastic session. So I want to invite our presenter for today, who is Mr. James, a colleague of mine, who is IT expert here at the agency, so that he can be able to take us through the session for the day. And I want to encourage you to ask questions, as many as you have, like we said before, which is related to IT, and as well as relating to any other topic that is relevant to our space sector. So let me invite our presenter. You can be able to introduce yourself. I've not introduced myself. Maybe I'll just do that, but I have done it on Monday. My name is Guyo Galgalo, and my background is in electrical engineering, and at the agency I support in promotion of research activities as well as education and outreach. So he will also introduce himself and then share his presentation for the day. Thank you very much. Thank you, James. Please.
Yes, thank you, Guyo, for that introduction. Okay, I'll introduce myself. My name is James Kurundo. I'm a software engineer at the Kenya Space Agency. My background is mainly in computer science. I mostly do software, sometimes hardware, and look forward to taking you forward through this webinar. So I think my presentation is being uploaded. You could bear for a minute or two. We'll get started. Okay. So before we start, you can, if you can't hear me, you feel free to interrupt me. And also, if you have any questions, feel free to interrupt. And as well, you can type questions in the chat, and my colleagues who are helping, such as Joshua and David, will assist you with answers as I go on. So again, if you can't hear me, make sure you feel free to interrupt me so I can adjust my settings. Okay, so we'll start. Today's webinar is webinar 36. It's about introduction to Scratch programming. So as we go for, so today is mostly about programming, but we'll be taught in Scratch programming. Okay. So as we move on to the next, today's overview will be an introduction to programming, an introduction to Scratch programming, the Scratch blocks, and an activity, an interactive activity, as well as a takeaway video. You can do it in your free time. Okay, to the next. So could anyone tell me what they know about programming? You can type questions in the chat. As well, unmute your mic and answer. So does anyone know anything about programming? If you've ever programmed before? Those in the chat, you can type anything. Okay. Okay. So programming is a set of instructions given to a computer to follow and accomplish a desired task. So in simple terms, a software program tells the computer what to do. For example, if whatever code you're writing could be Scratch, Python, or JavaScript, You're giving the computer some instructions to carry out a task and achieve a desired outcome. So at the root of it, program is just giving a computer instructions on what to do. You can tell it to upload a picture, you can tell it to download a picture, you can tell it to show certain colors on the screen. So programming is just giving it a set of instructions for the computer to follow. Before we move forward, can anyone tell me any programming languages they know? You can type answers in the chat. You can unmute your mic. Yeah, you can type in the chats. Oh yes, I can see Teddy has given a response to what a computer program is. A lengthy answer. Yes. Yes, so Teddy Nzioka has gotten a right answer. And can anyone type? Any programming languages they know? Okay, so I think you'll type as we go on. For example, programming language, an example is Scratch, as the one you're going to do. Ruby programming language, Python, JavaScript, Rust, C, Java, Swift, Go, and Kotlin. If you look here, these are mostly for mobile programming, except Go. Go is the blue mouse on the screen. These are mostly systems, and the top three after Scratch are used for web development. So all these programming languages are normally different domains. Their main role is to carry out a specific task. For example, this one is for website development. This one is for systems, operating systems. For Golang, it's used in cloud development. And Swift is for iOS apps. Kotlin is for Android apps. So all these have a specific domain, but they always tell computers, give computers certain instructions to carry out a desired task. So for example, Scratch, you can see we can use it for animations, games, and simple programs, as we'll see going forward. Okay. So what is Scratch? Scratch is a programming language that uses colorful code blocks to help you create interactive games and animations. Actually, Scratch is really good as an introductory language. For example, you don't necessarily need to write code. You just have to drag and drop blocks which contain certain code in them, and you'll be able to create an interactive program, an animation, even a simple game, as we'll see in the interactive part. So Scratch, the Scratch platform has 4 areas. So the programming palette, stage area, sprites, and a script area. So sprites are characters or objects that you'll see in the stage area. The stage area is where your code will be executed, is where you'll see the animations. So you can choose whatever code block to suit your situation. If you want your character to do a certain action, you get it from the programming palette. If you want your character to move up and down, you just get a block from the programming palette. Yeah, so the programming palette is mainly where in area. The design area is also the code area, or the script area is where you put your code blocks. That's where now the programming aspect comes, where you put it in a certain order, then the computer follows instructions in a certain order. For example, a script is when you click a button on the screen or you create a sprite or a character, it says hello with your name on it. This is quite easy to do on the Scratch platform, and it's really user-friendly. The code area is quite large, so you'll be able to see all your code easily. You'll be able to code in Scratch, which is a very beginner-friendly programming language, as you'll see going forward. So for a visual representation of the areas, as you can see here, is the programming palette. This is the most important part of Scratch programming. Here's where you get all your code. Just take it from here, drag it onto the design area, and it will be executed here in the stage area, as you can see. This stage area contains all the sprites, all the backdrops, all the code which is being executed. So here, once you write your code here, you always run here, and you see the animations, the games, the interactive programs being run here after you've written your code. So for this, for this page, as you can see, it's a Scratch platform. Everything you need is here, and it's quite simple to understand. You'll be able to get started quickly. So long as you know the code blocks, which I'll show you in the next few slides, you can drag them from the programming palette, put them in the script area, put them in the stage, then run them, and you'll see them execute the sprite and the stage area. Okay, so let's move on to the next part. So it includes the necessary tools for programming a sprite to do. It consists of the following blocks. The programming palette consists of the following blocks. Motion blocks. These are the blocks that give your character the ability to move around the stage area. For example, you can move it 10 steps to the right, up, left, downwards, diagonally, whatever way you want them to move. You can turn them 15 degrees at any direction. You can also move them across the screen or up and down, depending on whatever motion block you choose. So the programming palette, you can choose how to move your sprite to the motion blocks. So as you're going forward, you'll see how we'll use this. So look blocks. These are the blocks that make your sprite speak. For example, if you click on your sprite and you want to say hello, you can just drag this say hello. You can also put a time limit on it. For example, you can put 2 seconds when it says hello, then the look block disappears or the message disappears. This is quite interesting when you want your sprite to describe what it's doing, especially when you're creating an animation. The look block it gives you the ability to say hello. You can say it's thinking this. For example, there's a thinking animation for sprites, which you use this. When you want to say hello, you just write this. And there are many more. You can also change the background with the look block. This is quite easy, as you'll see going forward when you do the interactive session. So the next block is a sound block. If you want to give your characters certain sounds, let's say when saying hello, you can add it here. You can just upload your sound. Then also I'll use the look blocks which you've seen. Let's say you say hello here. You can also add a sound. Example, play sound. You can even stop all sounds. So the sound blocks gives the ability to the sprite to produce a sound or words that can be heard. So the next one is event blocks. These blocks do a task when an action has occurred. These blocks are important because, for example, an action can be when you click on a sprite, when you press a keyboard key such as space, escape, F1, F2, whatever keyboard you can assign it here. When you click, a certain action can occur afterwards. For example, if you click space, you can add a sound after it, and then the sprite will say hello. Event blocks are necessarily the most important blocks or most powerful. It gives you ability for you to interact with your sprite in a way that you want it to interact with it. And in the interactive session, you'll see how we'll use the events to carry out these activities. The next part is control blocks. So control blocks are mostly just conditions for you to carry out, for you to do code. For example, the repeat forever. This block will continue doing an action, whatever action you put in between this forever. For example, say hello. If you put a say hello here, the code will always say hello forever until you stop the code. Okay. And the repeat block will only say hello. If you put a hello in between here, it will only repeat for a number of times. For example, in this image, you can see it only repeats 10 times. So if you put hello inside, it will say hello. The sprite will only say hello 10 times. Afterwards, it will stop. Unlike this one, the forever block, it will say hello forever until you stop it. So next, we'll move on to the if-then block. This block of code is only executed when something is true. For example, if 1 + 1 is equals to 2, the sprite can say hello, or you can even say the answer is 2. Whatever you want, whenever you want your code to achieve, give it this instruction, the computer will execute and give you a desired outcome. Okay, so these are the control blocks. These are now how you control how your code is executed or how your code is run. Moving forward, you'll see how useful they are, especially in animations and games. These are really good code blocks to use. So next we have other if then else block. This block of code works only if a certain condition is true, and if it is false, it will do something else. For example, if 1 + 1 is equals to 2, then answer is correct. Else, you can put an answer is wrong. So this code here also can be used in addition to the other. If you want your code to execute when condition is also false, you can use this if then else instead of the if then block we've seen in the previous slide. So this work together. So it just depends on what you want to do and how you want to achieve it. So for example, as I said earlier, for the if then else, you can use if 1 + 1 is equals to 2, then answer is correct, else it is false. For example, you can also write if 1 + 1 is equals to 3, which is also wrong. You can write here else is correct. So it will check if if 1 + 1 is equals to 3. If it's false, it will go to the else part, then execute code which you put inside here, or any block you put here. If it is true, it will execute any code that's in between this part. So the next control block we're going to look at is repeat until block. This is just like an if then else block. If you want to execute code until something is true, and the if then block, as you've seen here, this only executes while it is true. If it is false, it won't execute. This, for example, will execute if something is false until it is true. That's why it's until. For example, repeat. If you write 1 + 100 is true, 1 - 100, 1 + 1 is equals to 2. It will, and it's true, it won't execute anything. But if you put something, let's say, if 1 + 1 is equals to 3, which is false, this will continue to execute whatever code is here until this part is true. So you have to make sure you have something that is true and can be achieved by the computer in the repeat until block. So next we have other blocks. For example, sensing blocks. These are blocks that make sprites detect or respond to the environment. For example, if you put a block, if you put a sprite which is color green, to detect that another sprite has touched it and carry out some code, whatever you want it to do. It's to sense. For example, if you put a ball on the page, I mean on your stage area, and once it touches the edges, it bounces. You can put touching edges instead of mouse pointer here. Once it touches the edges, then you can give it a bounce effect. It will bounce off the walls. We'll be able to achieve this in the interactive session going forward, but yeah, sensing is used to detect or respond to the environment. That's what sensing blocks are used to do. And variable blocks, these are used to make variables. So variable is anything you want it. If you want a variable to be a number, for example, variable 1 can be equals to 21, variable 2 can be equals to 23, whatever number, whatever word. For example, a variable x can be equals to hello, it can be a word, a number, or even true or false. Whatever you set your variable to be, you can make it using these variable blocks. And operator blocks. These are blocks that carry out mathematical calculation in the stage area. For example, 1 plus 1, 2 minus 2, 3 times 4, 3 times 4, which is equals to 12, this one is equals to 0, and this one is equals to 2. So for the operator blocks, if you want to carry out a calculation, a simple mathematical calculation, use the operator blocks. They're quite useful, especially when putting animations, as you'll see going forward. For example, if something is equals to 135, it carries out an action, as you will see in the interactive session. So the script is where the set of instructions that you use to create a Scratch program. As I said, that's where you'll drag and drop your blocks. You'll take here, moves 10 steps, put it here, and your sprite here in the stage area will move 10 steps from where it is. Okay, if you want it to turn 25 degrees, 15 degrees, it will turn 15 degrees in whatever direction you give it, either left or right. So the script area is where all the call blocks are put, and then the computer executes it and shows it on the stage area. So scripts interact with sprites and tell them what to say or do, as you've seen. When you put the move 10 steps on the stage area, on the script area, the stage area will reflect and the sprite will move 10 steps, going for 10 steps to the left or to the right, in whatever direction you want it to go. This the sprite will carry out the actions of the script. So you can create a script in the script area by dragging these blocks from the programming palette and assemble them here. So whatever type of script you want, to just take the blocks and put them in a certain order. In whatever order you put them is how they'll be executed. For example, if you wanted to move 10 steps, then turn 15 degrees, you put the 10 steps first, then under it you put turn 15 degrees. The sprite here on the stage area will move 10 steps, then turn 15 degrees in whatever direction you put. You can also add a glide, then once it does a 15-degree turn, it will glide to the other side of the screen, or up or down, depending on how you want it to be. Okay? So sprites. Sprites, as I said earlier, are characters. These are just objects, characters that could be created, could be added to a program already pre-built into the Scratch platform. You can use the every walk to move. You can use the ball, for example, for ball animation. You can use the ballerina. You can use Amon, Andy, and there are many more. For example, in our interactive session, we use a rocket sprite. You can find the option to add the sprite in the right bottom corner in the second menu from the right corner. There's an option on the platform which I'll show you where you can add whatever sprites you want, starting from the ball to the ballerina, all the way to rocket ships. Whatever sprite is there, you can add it. And you can even add your own. You can create your own and add them. So the stage area, this is where the program runs. It is a portion of the screen on the top right, with a full screen option also available. So the stage area uses X and Y coordinates to monitor the action with 0, 0 being the stage center. All actions by a sprite are performed here. So as I said earlier, this is where your code runs. Whatever code you put in the script area will run in the stage area. For example, if you put a block of move 10 steps, the sprite will move 10 steps in whatever direction you put it to move. All actions for the sprite are executed here. Once you put it here, the code is executed, and you'll see the actions of the sprite in the stage area. For example, this is an example of a stage area where if you click on any planet here, it will show you the name of the planet, as you'll see. Yeah, so now we move on to the second part, the activity 1, where you'll create the sprite animation. We'll go to the Scratch platform, which is online. You can use if you have your browser open, you can just go. Let me share my screen first. So the website is scratch.mit.edu. So this is the link to the website. I'll put it on the chat. As you can see, this is the Scratch platform. Okay, you are not able to see. Let me share. Yes. If you can see my screen, you can type in the chat. I'll be able to. No? Give it some time, it will share.
I don't think we see your screen, James. Maybe you can share it, please.
Okay, let me try and share again. Tell me if you see it. We'll take a minute. Is anyone able to see my screen? Yes, Tia can see it. Yes, Stanley can see it. Okay, that's nice. Okay, that's good. So here on the platform, if you want to start a new project, you can just come to create. And you'll immediately be taken to an editor. Okay. It's a minute to load all the sprites and the backdrops and the scripts. The programming palette in the stage area.
James, I want to interrupt. I don't think we see your screen from our side. Maybe members from the other end can confirm whether they can see your screen, please. Or you can just come and share from my computer, please. I think I can be able to share on your behalf, and then you can just work with them from this other end, okay? I don't know whether anyone can be able to see my screen from.
Yes, I can see a screen.
Right. James can be able to walk you through from this other side. Yes, you can just come over and then walk them through from this other end, please. I think it's your internet.
Okay. Okay, can you see the screen? Let me see in the chat. Can see the screen. Okay. Okay, so click on the chat. My colleagues will be able to tell me if you can see or not. Okay. So now I think everyone is on the Scratch platform. If you're not, you can always type and my colleagues will be able to assist me. So here, let's go to create. Here at the create, you will see everything that we talked about. For example, here is the programming palette. You have your loop block, your sound block, event blocks, control blocks, sensing blocks.
operators, variables, and your custom block. So as you've seen, we talked about all of them from motion, where you move your character, looks, you give your character the ability to say, to do whatever it is in the screen. You can also change the backdrop. You can see here, sound, events, the control blocks, example, the forever loop, if then, wait until, about, dancing, remember touching, example, if it touches the edge, the character can bounce. Operators, let's do mathematical calculations on the screen, and variable block. Okay, so this is the staging area, and this is the script area where you can drag anything. And, here is the sprite on the staging area, and here's where you get your sprite. Okay. Now we start with the rocket. Here you go to sprite, you choose the sprite, then you choose a rocket ship to add here. So you go here, the bottom right, you choose the sprite. You go here, type rocket ship, then click. You see a rocket ship on your screen on the site. So, for example, here you just set it to size of 40. Okay, so this now reduces its size and you can put it here. This is how you add a sprite here, and you click. So for example, we can add a block for this sprite to make it move. Okay, so here we can add an event that when it is clicked, we can have it move in a circle at the same position. So that's a loop block. We add the next costume. So now if I click here, as you can see, when the green flag is clicked, it will move. You can see it's moving in the same spot quickly and quickly without stopping. That's how you use code blocks to animate a sprite, but you can go further. Now we can add backdrops. Backdrop is just the background of the stage area. So for this one, I'm going to use a blue sky. You can see here, if I run, it just runs, but the backdrop will just remain the same. So we're going to add 3 more backdrops. Remember, this one is blue sky. And the next one, I'm going to put the blue sky too. Okay, hopefully you've taken we together, or is anyone behind or anyone joining? Okay. Okay, so we can add another one called stars. This one now gives it the ability to be in space. You have a rocket in space. Then you can add the last one, which is the moon. Now all the backdrops are here. So if you click here, then you go to the programming palette for backdrops. You can put them in a certain order, from blue sky all the way to the moon. Now animation is going to be the rocket goes all the way from Earth all the way to the moon, as you will see. Now, if we go back to rocket ship, if you click on it, you will still see the code. Now we can add another motion block where it does. It changes Y. When you say it changes Y, it means it moves from bottom to top. Sorry about that. Supposed to put the change by Y at the bottom, then you come here. Then from here, we'll set it at the start position. Okay. put it at x at 0, and y to 14 at negative 135. So you see, when you stop, start, it goes from top to bottom. Remember, it goes from top to bottom. Now you remember in the loop block, I said you can give the ability to say something. For example, say hello for 2 seconds. So if you write lift off and add lift off, it only says that for 1 second, then it moves up the screen. If we stop and start again, you see, lift off, then it goes up. So that's a simple animation, but we go further. Now, after in the forever block, we're going to add another event or control loop. If now here, if anything here is true, this some action happens, as we said in the control block. Okay. Now we're going to get a mathematical operator here. We're going to choose the greater than and put it here. Afterwards, we take a motion variable called y position. If it's greater than 135, whatever code you put here, once the y position passes 135, which is top of the screen, it will move to another backdrop. We'll put an event. It will broadcast message 1. Okay. And before we do that, we also want it to come down here to the bottom of the screen once it reaches the top of the screen. So that we put T0 is C. It's going up and down from the bottom to the top. Once it reaches the top, it goes to the bottom. That's because here, once the y position is more than 135, it goes back to negative 135, which is the bottom of the screen. Then afterwards, to broadcast a message, which will change which you're going to use the backdrop to change the backdrop. So if you want the backdrop to change, come here to backdrops, then you add another event. Yeah. When it receives message 1, the backdrop can change. Remember, the looks can change the backdrop. So what happens is, it goes to the next backdrop, you see, goes to the moon, goes up from ground, sky, space, then goes to the moon. And see the animation. So that's how it's carried out. Goes from there. In the bottom to the top, changing the backdrop. Okay. Okay. Are you able to see the animation? If you're able to see, can you type in the chat? Okay. 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 So I think you're able to see the animation. So now what we'll do next is when you click the lifter, starts from the ground, goes all the way to the moon. Okay. So for that, we add another event here on the backdrop, and when clicked, okay, it starts at the blue sky. the first blue sky. So now if I stop, I click to start here, go all the way up, starting from Earth all the way to the moon. Okay, if I stop, start again, goes down, then goes up. Now we move on to the next part. Now when it reaches the moon, we want it to land there and stop movement and say it has landed. So for that, we're going to use another event. So when backdrop, remember backdrop is the background, is the moon. We send a broadcast message back to the rocket ship animation. The rocket ship's character or sprite. Sorry. Now when it does that, it now broadcast a message which is gotten from the events block. It broadcasts another message, will create another one called message. Suppose this landed. Okay. Now go back to the rocket ship here and stop it. Then when I receive landed, remember when you receive landed, is where you receive the broadcast. So this one, when you receive landed, you can stop all the scripts. And so that's a control block. So you add it, and now you run. See lift off, and then it stops on the moon. You can run again. You can customize it as much as you want. And see, now here you can go back to you can add a few more events. For example, when the backdrop switches to the moon, and add a message. Or rather, instead of this, you can add a message here. We are on the moon. Okay. Now if you run, you go up from the ground. There's an error there. Okay. Going to add more of the sake. Okay, now it should work. Isn't. Here, if you go back to the backdrop and fix the error, the error is here. If you go cast landed, you can add a few more messages. When for the sprite, so you think here we can add an event when backdrop switches to stars, says we are in space. Put it to say this for 1 second, and then we run. You will see once it reaches space, it stops on the moon. Okay. Then when the broadcast is received, it says we are on the moon. Now it should work, all of it. Okay. I think there's a problem here in the site app, but as you can see, it's quite easy to make an animation. For example, lift saw, it says you're in space, and it goes to the moon. You can make it move slower, lastly with this piece of code by making it wait a bit here. Put a 0.1 seconds, then now it will move. Yeah, as you can see. In space, and it lands on the moon. So as you can see with Scratch programming, it's quite easy to create a simple animation with it. It doesn't take much time. It won't take 15 minutes, other than the network problems we've been okay. And we've been able to create a simple animation, rocket lifting off from Earth. You can see, goes and lands on the moon. Simple animation with very little code. You can see here. It starts here on Earth, this is the moon, and all the code that you can see is less than 20 blocks. If it's less than 20 blocks, I think you can even do this in less than 10 minutes, if not for network problems. Okay, so I think that's the end of the interactive session. If you have any questions, you can type them in the chat.
I think that has been a very insightful session for Madam, and I want to thank you for that great presentation. I believe most of us have benefited from this introduction to Scratch programming, and I want to welcome you members who have joined us to ask questions. If you have them, you can just raise your hand, and then you will be unmuted, and then you will ask your question to James or any other person, or any question that relates to that is relevant to the space sector. Please, the floor is yours. You can ask questions, please. Anyone? I can see Michael Mwanzia is typing. Someone put buttons. Okay, so someone can answer from David James. You can. I don't think we can hear you. I don't know whether you.
Hello. Can you hear me?
Michael, you can go ahead, please. I think you have been unmuted. We've heard you, but we have lost you again, please.
Hello.
Yes, we can hear you. Please go ahead.
I was asking, for example, in the animation, you see the rocket going up, and then with some editing, you can make it go down. say if you want to turn it into a game and you have real-time control with the rocket. Is it possible to do that, like linking the movement of the rocket to a certain button, maybe the up arrow for the rocket to go up and the down arrow for the rocket to go down? Hello?
Yes, yes. Thank you. Thank you for the question. I think James has got it in the I don't think we have had my colleague. Maybe he can just hear from my end his thoughts.
Okay. Yes, you can move it up or down, depending on how you want it to go. The choice is yours. Is that okay?
I think, Michael, I believe you have been answered. You can be able to add buttons as long as you want it. James is the expert, and he has said yes, it's possible to add buttons. Yes, yes, Michael has responded. Yes, thank you. Karibu sana, Michael. Any other question from the members who are in attendance, please? You can just raise your hand or share your question via the chat box down here. And I believe it has been insightful session again. I repeat. And I want to invite you as well tomorrow for another Space Club webinar series. We will be doing it the whole week. We started on Monday, and yesterday, of course, it was a public holiday. So we had another one today on introduction to Scratch programming, and we hope to have introduction to satellite ground station. I'm sure that will be interesting as well for space enthusiasts to be able to learn what ground station is and how ground station works. So I don't see any other hand raised. Maybe I'll just share the poster for tomorrow's webinar quickly before we close. Right here. So let me share my screen quickly. Okay, there we go. So we started on introduction to geographic information system. I believe you can see my screen. And today we did introduction to Scratch programming. Tomorrow we intend on doing introduction to satellite ground station. And I want to welcome you all to attend this session. Be able to learn and understand how ground station works and how ground station receives data from satellite in space. So let's there is any other question. I don't see there isn't any other question. So we can close this session and I will hope to see you tomorrow. Okay, I can see Mondia has raised his hand. Please go ahead.
I have a question in relating with the virtual programs already created or the simulations that are being used now with the NASA for testing out landing situations like lunar landing and Mars landing. Is this like using these Scratch programming classes or events that you'll be taking us through? Is this like a precedent to?
Yes, I think the purpose of this webinar is to be able to educate you, to educate students, and inspire them to come to solutions. Okay, so this is just a stepping stone, a learning procedure, so that a better version can be built out of such a program, for example, the Scratch programming. But this is not what will be used, of course. So this one is just for kids to be able to like build their capacity, inspiring them to venture into the fields of STEM, science, technology, and engineering, and of course programming. Okay, but the one for the one that you mentioned, going to the moon and the lunar landings, those are complex issues, but still you can be able to build up from what we have done today. Yeah, I think that is it, Mavia.
Okay, thank you.
Karibu sana, and I hope you guys have enjoyed, and we have also enjoyed having your company until tomorrow, the same time, 2:30 to 3:30. But strictly tomorrow we'll be starting at 2:30 on introduction to Jam Station. Thank you very much, and bye bye.